Hello. In today's lesson, we're going to explore exponent more. Like yesterday, we saw square root and then cube root. They are all form of exponents. But how do we work with all these exponents? So we'll look at the laws of exponent, some of the laws, of exponent. And then we work examples with them. If we could not finish with the loads, we'll look at some of them and then maybe continue later on. And then we will look at negative exponent. We investigate negative exponent. So these are the two things that we'll look at: negative exponent. Yeah. So these are the two things that we will look at, and then the zero exponent. Then zero exponent. So we look at these three, and yeah, you apply them when we get to all the laws or working any exponent. If you know the rules, then if you come across any exponent, you'll be able to look at it. We'll first look at negative and then zero. You first look at negative and then zero, and then after that we look at the laws. Let's look at negative and zero. After that we look at the laws. Yeah. So we know that any number, so first of all, for zero exponent, it's simple. All that you need to know is that any number exponent 0 is 1. Any number or anything, let me put it that way, anything exponent 0 is 1. Any number exponent 0 is 1. And then, so any number exponent or index exponent 0 is 1. Exponent, another word that you can use for exponent is power raised to the power. So in some books, if you don't see exponent, you see raised to the power, it's talking of the same thing. Or if you see index, it talks of the same thing. So we will say that, like, if I have 2, I need to make this one bold, and then I'll be able to move around so that everybody can see. Okay, so any number exponent 0 is 1. So let's say, for example, sorry for the mercy, I need to two exponent 0 is equal to 1. 156 exponent 0 is equal to 1. So any number raised to the power 0 is equal to 1. And then 7 exponent 0 is equal to 1. So any number raised to the power 0 is equal to 1. So that is 0 exponent. We will come, and then you know the proof of it when we're doing the negative exponent. So let's look at negative exponents too. So for negative exponent, let's say if I have 2 exponents -1. This one is going to give me 1 over 2. 1 over 2. That is 1 out of the positive exponent of the number that you are looking at. That is negative exponent. Negative exponent is 1 out of the positive exponent of the number. Let me go quickly, and then you could just, the proof is not something that you have to memorize, but just to show you how it works in case you come across something that you forgot to be able, or if you are teaching some younger person, then you may be able to tell the person why we have any number exponent 0 is 1. So let's use this for example. Let's say let's say 2 exponent 3. We know that 2 exponent 3 is 2 times 2 times 2, which is 8. So 2 exponent 3 is 8. Let me do it this way. 2 exponent 3 is equal to 8, which is 2 times 2 times 2. Now, if I reduce this by 1, go to 2 exponent 2 is equal to 4, which is 2 times 2. How did I get that 4? We found out that 8 divided by 2. 8 divided by 2 gave me the 4. 2 exponent 1 is equal to 2. And then 2 exponent 0 is equal to 1. 2 exponent -1 is equal to 1 over 2. 2 exponent -1 is equal to 1 over 2. So now let's see. I don't know how to, I'm not able to get my distance set up right. I need to check my pencil. Okay, so we said 2 exponent 3 when the exponent was reduced by 1. Like you see, each step we reduce the exponent by 1. So 3, 2, 1, 0, -1. And then for the answer, we divide the previous answer by 2 to get the answer for the next one. So here 2 exponent 3 is 2 times 2 times 2, which gives us 8. So when we go to 2 exponent 2, when this one was, the exponent 3 was reduced by 1, we divided the 8 by 2. And then we had 4. When this 2 was reduced by 1 to get 2 exponent 1, we divided the 4 by 2. So 4 divided by 2 gave us 2. And then when the 1 was reduced by 1 to get 2 exponent 0, we divided 2 by 2, which gave us 1. Now the 0 reduced by 1 to get -1. So 2 exponent -1 is going to be 1 divided by 2. So it's the same 1 divided by 2 exponent 1. If we should continue to still reduce this by 1, it's going to be 2 exponent -2. So that is going to give us 1 out of 2 divided by 2. So 1 out of 2, let me use this division sign, and then you understand it well, divided by 2, which is the same as 2 out of 1. So this one will give us 1 out of 4, which is 1 out of 2 squared. Because you reciprocate the division of fraction. You reciprocate this, the second fraction, and then you change this to multiplication. So that is how we got the 0 exponent and then the negative exponent. The zero exponent and then the negative exponent. So this is it about the zero exponent and then the negative exponent. So let's look at few examples. This is that simple, that any number exponent 0 is 1, and any number exponent, any negative exponent is 1 divided by the positive exponent of it. So example, 3 exponent 0 is equal to 1. 39 exponent 0 is equal to 1. If I have 5 exponent negative 2 is equal to 1 divided by the positive of this one, 5 exponent 2, which is 1 out of 25. 5 exponent 2 means 5 times 5, 1 out of 25. So that is how the negative exponents work. Let's say 7 exponent negative 4. It's going to give us 1 out of 7 exponent 4. 1 out of 7 exponent 4. So that is all you do for 0 and then negative exponent. 0 and negative exponent. Now we're going to look at the laws of exponent. So exponents laws. So I'm going to just state all the laws there. Then we look at examples with them either today or next time. So just need to get this thing to be bold. So exponents law. So I'm going to use A and B, which are rational or variable based, and M and N are integral exponent. So what I'm going to use, so A and B, A and B are going to be my rational or variable base, are going to be my base, and then I'm going to have M and N to be my integral exponent. So in all these laws that I'm going to put there, all the A and B will be my bases, and then the M and N, where we have them, are going to be my integrals. So the first law that we're going to look at is product of powers. That is the product rule. Product of powers. That says that A exponent M times A exponent N, this one is equal to A M plus N. A M plus N. A M plus N. So if I have, let's do an example, 3 exponent 2 times 3 exponent 5. This should give me 3 exponent 2 plus 5, which is 3 exponent 7. Which is 3 exponent 7. Note, ensure that the bases are the same. A and A, 3 and 3. So you only apply this when the bases are the same, product of powers. When the bases are the same. So when they have the same base, that is where you apply this rule, rule 1, or the product of powers when they are the same base. Let's look at another example. So let's say 6 exponent 4 times 6 exponent 1. So this one going to give me 6 exponent 4 plus 1, which is 6 exponent 5, which is 6 exponent 5. So very, very important. Let's look at another example. 8 times 2 exponent 2. How do you do this? Do you do 2 exponent 1 plus 2 or no? Because the bases have to be the same. So what you have to do is you have to make the bases the same. So 8, we can write 8 as 2 as a base. So 8 could be written as 2 exponent 3. That is 8. And then 2 exponent 2. So in this case, you can have 2 exponent 3 plus 2, which will give you 2 exponent 5. Give you 2 exponent 5. So when the bases are not the same as in this example, you try to make the bases the same. You try to make the bases the same. That is very, very important. But let's look at one more example. 5 exponent 8 times 5 exponent negative 3. So in this case, the bases are the same. So you're going to get 5 exponent 8 plus negative 3, which is going to give you 5 exponent 5. 8 plus negative 3 is 5. Give you 5 exponent 5. Give you 5 exponent 5. So you just apply it as you see it. But what you need to take note is the bases should always be the same. The bases should always be the same. So I'm going to give some examples for you to work out. We're not going to. So we're just looking at this rule, just this rule. Next time we look at the other rules. So worked example. Yeah, I'm not going to work this example, but you should work it and then let me know your answers. 1. What is going to be 9 exponent 0? 2. What will be 15 exponent negative 2? 3. What is 17 exponent negative 1? 4. 1587 exponent 0. 5. What is going to be So here the bases are the same, so you can still work it out. The bases are the same, you can still work it out. So that is it for today. So that's going to be your work that you're supposed to do. The simple ones. So going over everything that we did, we talk of um, yeah, we started with integral exponent. And then we talk of zero exponent, that any number exponent. Zero is 1. We talk of negative exponent over here, that the negative exponent of a number is 1 out of the positive exponent of that same number. One of the positive exponent of that same number. And then we work some example. Now we look at the laws of exponent, and we just look at the product, power of product. We say that when the bases are the same, and they are multiplied, you maintain a base and then you add the exponent. So when you have a and a exponent m, a exponent n, a and a are the same, so a exponent m from here, this m, plus this n. That gives us a exponent m plus n. That's an example. 3 exponent 2 times 3 exponent 5 is going to be 3 exponent 2 plus 5, which gives us 3 exponent 7. 3 exponent 7. Let's look at this particular example. Over here, 8 times 2 exponent 2. The bases are not the same. So what you have to do first is you make this base the same. You write the base to be the same. And you can write 8 as 2 exponent 3. So 2 exponent 3 times 2 squared. So now the bases are the same. So you can have 2, 3 plus 2, which will give you 2 exponent 5. 2 exponent 5. So that is it. And I want you to complete this 6 week. To complete this 6 week. Tomorrow we continue with the other basis. Oh, sorry, the other laws of exponent. With the other laws of exponent.